Thank you for coming. We're going to talk about enterprise DevOps. My name is Lee Eason, and I am the Director of DevOps at Iprio. Iprio is a large financial services company, financial technology company. We have customers that range in size from small, privately funded private companies, use our products to do things like figure out what their valuation is, handle compliance-related documentation that they have to track, helps them keep track of when they make promises to employees about stock, stock options, when they're going to go public, when they're going to get acquired. And our customers range from there all the way up through the largest investment banks in the world. So that includes people like Bank of America, Morgan Stanley, JP Morgan, Goldman Sachs. The other day we had a candidate on site, kept calling him Goldman Socks, which we all really great kick out of. By the way, I got some sweet Datadog socks here. So big shout out to Datadog. They told me not to tell anyone they gave me socks. So go down there and ask for socks. It's been a wild ride coming to Iprio. I'm lucky to have several friends in the audience. I've worked with many of you guys in the past. And coming from where I came from, small open source companies into the world of Iprio, it was quite a transition. My challenge was trying to take the things that we did well in a small company and figure out how to make those work in a big company. And so that's the goal of this talk. The goal of this talk is to help you understand what the unique challenge of enterprise DevOps is. It's security fast. Okay, and we're going to talk about how to overcome these unique challenges that come along with trying to do security fast. So before we get too much further, I want to give you a warning. This is not a sexy talk, okay? And you know what I mean by a sexy talk. At many of these talks you're going to come to today, you're going to come in, the speaker's going to have rose petals on the stage, he's got candles, the lights dim, and he starts telling you about the sexiest automation pipeline that you've ever seen in your life. Yeah. You're sitting in the audience and you're soaking it in. It's like Kelsey's talk this morning, when he's deploying code by talking to his phone. I was like, oh yeah, I want that. So you're sitting there you're absorbing it all, right? And you're thinking, I'm going to take this straight to my company. He's showing you Kubernetes. It's got monitoring, orchestration, health checks, automated rollbacks. You're like, yes, I want all that, just like that. But then the speaker says something that throws you off. If you're like me, he says something like, deploying code is easy. All you have to do is push code to master. It gets tested and pushed straight out to production. And I go, I can't do that. Okay, I can't. That's crazy talk. But it's fine. We'll just use some approvals, no problem. But then he really throws me off. The speaker will say something like, pushing infrastructure changes is easy. We use Terraform. All you have to do is type Terraform apply. Any developer can push production infrastructure changes out. And I go, wait. I can't. I spend the next 30 minutes trying to figure out how I'm going to take this super sexy automation pipeline and make it work. I was thinking this morning even, I'm not pooing on Kelsey, I'm super jealous of his talk. I wish I could do that. I was thinking, what if I went to Bank of America, Barry, and I said, hey, let me show you my change control process. Okay, Google, push code to Bank of America. Like, they would literally have kittens. And I'd have to find homes for those kittens. We'd have to give them shots. It is a lengthy process. There's no way that my customers are going to accept that kind of change control process. But I want to be able to push code that easy. I want every team in my company to have that kind of experience. So that's our challenge, right? That's our challenge in enterprise DevOps. So let's talk about enterprise DevOps and make sure we're all on the same page, because these two words kind of don't really go together, right? Shakespeare might have said, two terms both alike in dignity, and fair Raleigh where we lay our scene. What's it from? Thank you. Geez, holy cow. All right, no, thank you. 200 gold stars for that guy. Enterprise DevOps. So I wanted to be really scientific about how I defined the term enterprise. So I asked my LinkedIn network. You're always going to get honesty from your LinkedIn network. The answers that I got back kind of fall in these dimensions, and I jive with this stuff. This makes sense to me. There's no really good, clear, concise definition of enterprise software companies, but what makes us different than other kinds of software companies are these types of things, right? You either have lots of customers or you have a few customers and they're really, really big. You have more than one product or line of business, so you're not just selling one thing, you're selling lots of things. You provide a service to your customers that's not just a value add. It doesn't just make their jobs easier or faster or what have you. The thing you're selling to your customers is the core nugget of what they sell. When we sell IPO software to our customers that they use to take Facebook, Alibaba, Snapchat live, which we've done, that was all us, those banks exist to take companies live. If our software doesn't work right, those businesses can't do what they're here to do. So we're not just adding value, we are enabling that business to exist. That's a very different kind of relationship than somebody that might be selling a smaller like workflow enhancement tool. We have complex technological landscapes. Why? Because many enterprise software companies have grown through some organic growth, so they've written new services and products. They've also acquired companies, right? And on paper, those acquisitions look great because you're adding some nice piece of business to your portfolio, but the technology is completely different. So you used to be a Microsoft company. Well, guess what? Congratulations, now you're a Linux company too. How hard can it be? You just make the Linux thing work next to the Microsoft thing. What's the problem, right? So you end up with these really diverse landscapes. You're multinational. Okay, I was just talking this gentleman down here in the front about this. You're selling products in Europe and Asia. Well, guess what? The financial laws and regulations in Europe are completely different than they are here. The penalties for violations are completely different. And you have to be able to navigate all those landscapes. And when you're dealing with data, customer data like we do, you have to understand how the different legalities in the different places you operate affect your business. Okay? Finally, the thing I'll say is that my impression after working in different kinds of companies is that when you're in an enterprise software company, security comes first. It is the absolute like job zero of everyone in the company. You have to be considering it before you do anything else. It's not something that you tack on at the end. Then we think about the word DevOps, right? Everybody at these conferences gets to give their definition of DevOps, and I'm not going to miss my chance to do that. My personal definition of DevOps is a culture of continuous improvement applied specifically to code, build, and deploy processes. Okay, so we always want to be continually improving in any software company. Fine. DevOps is just putting a magnifying glass over your code, build, and deploy processes and making sure that you're doing continuous improvement there. We tend to focus on the implementation of that culture, and that's great. That's the sexy talks. But at its essence, that's what DevOps really is. So what's nice to me about that definition is it's sufficiently vague to get funding from a CFO, but it's specific enough for your teams to actually do something with it, right? Articles, when you go online and read about DevOps, though, they tend to focus on single technology stacks. You're not going to find too many articles that show you how to deploy a .NET core application right alongside a Ruby on Rails app. They're going to focus on one or the other. And most of the time, it's the Ruby app. Most of the time, the materials you find for DevOps are small, lean teams. There's not a lot of talk about, cross-team dependencies or the kinds of workflows that most of us have to encounter on a day-to-day basis. Finally, I'll say that my impression, and again, it's not that security is not important in smaller companies, it just tends to be this thing that you sort of do near the end of a process. The workflows tend to come first. We tend to value ease of development over making sure every hole it could possibly be there is found and plugged. So I'm going to give you 4 keys to how to do enterprise DevOps successfully. Everybody says never do more than 3, but I didn't want to cut anything out. So we're going to talk about 4 things you need to get good at in order to do DevOps well in an enterprise. We're going to talk about how to classify your data. We're going to talk about how to deal with risk. We're going to talk about an internal tools team, and then we're going to talk about site reliability engineering. So number 1, we're going to talk about data classification. So this is the process of looking at the data that your company is responsible for and putting it into buckets. There's 3 dimensions that you need to be thinking about when you're bucketing your data. The first one we're going to talk about is confidentiality. So when you're thinking about the data that your company is responsible for, it's going to fall into some category of confidentiality. It could be public, right? You could be taking SEC filings, EDGAR filings, like 13F filings. That's public data. If that gets leaked, it's probably not that big a deal, okay? You could be taking anonymized public healthcare records. Many times, healthcare companies will anonymize these things and release them to the public. That's public data, right? The way that you should always be thinking about how you're going to be classifying this stuff is the impact to what happens if it's misused, what happens if it's mishandled or leaked to the public. So public data is already public. We don't care. It's already out there, right? The next category you might need to think about is company confidential data. All right, this is data that, if it were mishandled, represents a risk to your company specifically. So maybe you took that public data and you put some secret sauce on it. You have some custom algorithm that you've added some value to the data, and you're using that data to sell services to your customers. If that data were leaked, then maybe they don't have to buy your services anymore. It could put your company in a business risk. There could be reputational risk to data being leaked. A company I worked at one time, we were trying to classify our source code. And the conversation was interesting because when we first started talking about it, it seemed pretty obvious that it was company confidential data. But as we started thinking about the impact to what happened if this company's source code was leaked to the public, it was a damage high enough to bump us into the next category in terms of what the impact would be, and that would be customer confidential information. So this is a case where your customer has entrusted your company with some of their own data or their users' data, right? Now we're getting into situations of PII, personally identifiable information. There's a whole bunch of laws in different countries that dictate how you need to be controlling PII. So if your customers are trusting you with that kind of data, you might need to classify that differently than just company confidential data, because there may be laws and regulations and there may be impact to that being leaked that's above what your company's data being leaked would be. GDPR, I was just telling this guy up front about this, is a set of laws that have been in place in Europe for a while, but there's a revision going in now that's, I think, what is it, $10 million per, or 10 million euro, excuse me, per infraction. So if you have a database with 100,000 records of people's information and it gets leaked, that's 100,000 instances of a violation. That is a company-ending event. So you're talking about a set of data that you've got to be really, really careful about, and appropriately so, right? We have a high responsibility here, but something you need to be cognizant of. The second dimension to consider here is the environments that are in play. Many times, enterprise software companies with our complex technical landscapes, we have data in lots of different places, right? You could have physical co-located data centers. You could have public cloud resources, private clouds, so maybe you've partnered with Red Hat or IBM. You could have offsite backup locations. Hopefully you do, if you're using co-located data centers. Each one of these locations is important because each one carries with it its own set of controls that you sort of get along with the fees you pay that company. These locations will have some sort of security framework certification that they publish and maintain. And that way, when you're thinking about the controls that you're putting on your different classes of data, you can leverage that location's controls as part of that. They'll be different, so you need to consider those things. And the last dimension you need to consider here is the interaction method. And this is pretty simple, right? You're usually either using data, it's in transit in between endpoints, or it's at rest. That's about it. So what you're going to do is you're going to build this matrix of confidentiality, environment types, and interaction methods. And for each one of the intersections of those things, you're going to establish a list of controls that must be in place in order to certify that you are using that data appropriately. This is the bedrock of enterprise security. If you don't have this, if your internal teams don't understand this about your company, this is a big opportunity for you to get one nice level playing field for everyone to have. You're going to build everything else that you do in terms of process on this foundation. The second thing that's going to make you successful as an enterprise software company doing DevOps is risk mitigation. Risk mitigation is an interesting thing. It's not cut and dry. It's not black and white, typically. The process typically looks like this. You have a conversation at your team level. You identify some risk. There's something that could go wrong. And immediately what you're going to do is look back at your data classification document, and you're going to check to see if the controls are in place that need to be in place in order to mitigate that risk. And if they're not, you're going to look at the level of effort that it's going to take to mitigate the risk, right? The effort here is not to eliminate all risk. It's to get rid of a point. It's to get to a point of where you've eliminated inherent risks, and you get to a point of residual risks. What does all this mean? What this really means is that there's probably a set of reasonable things that you can do, controls that you can put in place that take care of your data according to your data classification document. But there will always be situations where you can't eliminate all risk. I'll give you an example. Let's say we are migrating data from my co-located data center up to the cloud. The process that the team has built to do this takes data from a data store in our data center, it does some processing on it on a server, and then that server pushes the data up to the cloud. So the first thing that we're going to do is refer to our data classification document. We're going to say, what's the nature of the data? Okay, it has PII in it. PII could be anything. It could be an IP address. It could be an email address. These are all PII, right? So if you have that kind of data that you're dealing with, we've already fallen into customer confidential data. And so we can look at our data classification document and see exactly what controls need to be in place. So there's certain types of encryption that need to be there, right? Then you're going to look at the process itself, and you're going to see, have we eliminated all of the inherent risks with this operation? As far as we can tell, we have. But there is a residual risk. The residual risk is that some people in our company have access to that server. And they could, if we had an internal bad actor who was aware that this thing was going to happen, they could access that server and they could glean some of this information off during the transfer process, right? We can't make it so that no one can get on the server, so there's going to be some people that have access to it. So what you're going to do now is have a conversation about who can accept that residual risk. Is it the developers involved with the migration process? No. Why not? Because they're the people who we think are part of the residual risk. The people who have access to the box, who could be an internal bad actor. If they're the people that we think we're at risk from, obviously we can't go to those people and say, do you accept this risk? Because they're just going to say, yeah, sure, I accept the risk. That's a conflict of interest. This is the kind of maturity that you've got to help your culture, help build as a culture inside your company. So you've got to teach your teams about how to identify risk, how to talk about these inherent risks, how to talk about residual risk, and how to identify who can accept risk. So you would need to escalate this conversation to a product owner or product manager, someone who has some responsibility over the customers associated with that data, explain the situation to them, help them understand what's going on, and give them an opportunity to chime in. Maybe it's worth taking an extra couple of weeks to change the process so we eliminate that residual risk. Maybe we're okay accepting the risk. The key here is that you have to be able to have the conversation and document the results. So that's risk mitigation. So we've talked about how to classify our data. We've talked a little bit about how to deal with risk. We're not trying to eliminate all risk. We're just trying to get to a point where we feel comfortable accepting these risks. Now let's talk about building an internal tools team. So when I joined iPrio a couple years ago, we had a legacy release management function inside the company. Now, the way this worked is that if Team A needed to deploy code, they would ask the release management team to package that code up for them and deploy it out to production. They'd have meetings, they'd coordinate, they'd do practice runs. This is a very typical way that enterprise companies deploy code. So what I did was convert that team into an internal tools team. The focus here is we're trying to get from a model where we're giving people fish to a model where we're teaching people how to fish. So you've heard the expression, if you want to feed a man for a day, you give him a fish. If you want to feed him for the rest of his life, you teach him how to fish. The internal tools team needs to teach people how to fish, right? And they own a set of tools that serve as the bait, the tackle, the fishing line. Those are the tools you need in order to be able to fish, and they have to teach people how to use those tools. A release management team is just handing people fish. The problem with that model is it doesn't scale. It has inherent quality problems. We know that that's not the right way to structure our build deploy process. And when we apply DevOps to that process, when we apply continuous improvement to it, you're going to end up in this model, right? So at iPrio, it worked for us to just convert this team to an internal tools team. And so they went about the process of seeing what are the gaps, what's missing. I can't teach someone how to fish if I don't have a fishing pole, so I got to get that, right? So I can't teach teams how to manage their build process if they don't have access to a build server. So we have to make sure we have that in place. We have to make sure that collaborative code development tools are there. So we need a GitHub or something like that. You're going to have to look at the landscape of your development environments and figure out if there are any gaps and make sure you've got a team in place that can own those things and continually make improvements to them. People, when I first joined iPrio, said, who's going to be on the DevOps team? And I was like, oh, God, we're not going to have a DevOps team, right? That's not right. If you have a DevOps team, please don't. Just don't do that. That's not the right model. You don't want a DevOps team. How can you have continuous improvement of your code build and deploy process if only one group of people are thinking about that, right? So what you've got to do is you have to build a culture of continuous improvement across all your development teams. My answer to those people was, you're the DevOps engineer, and you're the DevOps. I'm like Oprah. You're the DevOps engineer. We're all DevOps engineers. So you have to teach these folks. You have to set up processes. We use things like guilds, lunch and learns, training opportunities, book clubs. We make sure and incentivize the kind of behaviors that we want to see, right? So if someone does something awesome, like I see Zach out in the audience here, Zach, you rock. When Zach does something really cool, we try and go on Slack. We try and go in Inside Technology, and we talk about how, great, look at us. Look at this team over here doing zero downtime deployments now. How many financial technology companies have products that deploy code during work hours with no downtime? It's not very common, but we're doing it, and we're doing it because we're incentivizing the right behaviors, and we're enabling those behaviors through an internal tools team. The last thing I want to say about internal tools is I want to give you a hearty recommendation to make sure you use a service desk to track any issues or help requests with your tools team. Why? I'll tell you a story. So when we first rolled out Splunk at iPrio, that's what we use for all of our log monitoring aggregation. Yes, you can yell at me about that afterwards. So we use Splunk, and actually our teams love it. It's been a game changer for us. When we first rolled it out, there was this idea that, hey, once we create the indexes, they're not going to change that often, right? We're just going to create the indexes one time, we're going to hand them to our teams, and that'll be that. They're not going to change that often. And we'll create a help desk ticket in our tracking system. In case anyone does need to make a change to it, they can just use this form. It'll be easy peasy. We'll just make the change for them. Because we track that data, we were able to monitor the frequency of those requests. And we found out I was dead wrong about how our teams use indexes in Splunk. And the rate of change for those indexes was way higher than I thought they were going to be. And I see Talby out there. He's on our team for the tools team, right? So Talby watched the frequency of these requests coming in, and we said, wow, it's sustaining. It's really high. It's not going down at all. We need to figure out what to do about this. So with the data, you can say, okay, well, how much time do we spend answering those tickets? How much time is it going to take for us to automate it? And now we just do some simple math. Is the ROI on automating that process worth it? Is it there? Obviously, it was for us. So we went and set up a GitHub repository. We use GitHub Enterprise. And now if a development team needs to make a change to an index, they just make the code change themselves. They submit a pull request. Our team does a code review. If it looks good, we just accept the code review. It goes into our build system, and that build system deploys the config changes out to Splunk that evening because it needs downtime. And that has been a game changer for us, right? So now we don't spend time creating indexes or making index changes for our teams. They can do most of that work themselves, and now we can use that time on something that's a lot more valuable to the rest of iPrio. If you don't have that data, you won't be able to make intelligent decisions about how you evolve the self-service aspect of your tools. None of that stuff comes for free. Automating any of these things takes an investment, and you need to have the right kind of information at hand to make an intelligent trade-off. Just to share kind of what our internal tools structure looks like, this is the tools that we use at iPrio. Our developers have found it really helpful to have a resource like this chart. So new developers come on board, and they're curious about, what do I have? What are the tools in my toolbox? What can I use? How do they work together? We can say, hey, go to Confluence and look at this beautiful chart and click on those icons and you can learn more about it. Yes, we use TFS. I'm not ashamed. We do thousands of deployments a month with TFS. It works. It works well. All right. Let's talk about site reliability engineering as our last point. So we've talked about data classification, we've talked about risk management, we've talked about building an internal tools team. What's reliability engineering? So site reliability engineering is a concept that Google created and published a book about in 2004. Ben Traynor wrote it. It was a pretty game-changing book at the time. Google was being very transparent about how they manage their teams and how they manage their products. That predated the term DevOps by about 4 years, 4 or 5 years. When DevOps became a fad, Google engineers sort of scratched their heads and said, we wrote a book about this 5 years ago. Like, why is this a thing? This isn't a thing. DevOps is not a thing. It's just how you do your job, which I find kind of funny. So what is site reliability engineering? Traditionally, the purpose of site reliability engineering is to make sure that the products you're building will be able to hit a certain uptime goal, okay? So you have to look at the product you're building. The team has to decide based on the market, based on the customers and the product that they're deploying, how much downtime can we afford in a given year? You come up with some number, 99.999999 times infinity, right? Whatever that is. That translates to a certain number of minutes that you can be down. The site reliability engineering model says you can spend those minutes however you want. It's like a bank account, right? Like when I went to college, I had a certain number of demerits that I could get before I got thrown out. It was like a bank account. I can just spend them, right? So this is how these teams think about their downtime now. They call them error points. So SRE will work with the team to help them figure out how many error points do you get in a year. Then SRE works with the team to get really deep on how they built their product. They're going to talk about high availability, disaster recovery. They're going to have the team demonstrate all the different tests that they've done to make sure that things are actually set up the way they said they were set up. At the end of the exercise, the SRE team is going to say, based on all the stuff that we've looked at, we calculate that you're going to incur more error points in a year than you say you should be able to handle. So you don't get to go live. You actually need to fix this list of things first. So SRE acts as a gate before a product can go live. And again, the focus traditionally is uptime and reliability. Another nice side benefit to SRE traditionally is you have a consistency in practice across products. Okay, so you probably won't have one team doing backups dramatically different than another team. You're probably going to have these teams using a common backup solution. And that's a good thing. You don't necessarily want lots and lots and lots of variance across your teams for that sort of thing. Now, how does SRE map into the enterprise? My proposal is that we add in a couple of key things to make SRE work for an enterprise software company. Namely, we're going to talk about compliance monitoring and control objective owners. All right, so what's compliance monitoring tools? How many of you guys have seen demos on AWS Config? Anyone? No? Yeah, a few? What AWS Config does is pretty slick. If you have resources running in AWS Config can check to make sure that the way you've deployed those resources meets certain criteria. And you can wire AWS Config up into CloudWatch. You can get monitoring on those things. You can also wire it up into Lambdas, and you can use Lambdas to nuke those errant resources from orbit. It's the only way to be sure, right? So the nice thing when you use AWS Config, you've got this continual compliance monitoring in place that's checking to make sure no one ever violates the rules. And if they violate certain rules, you can actually automatically roll those things back. There's some really great online demos that show, for example, someone deploys an S3 object and it's public. So maybe there's a rule you have in your organization that says, no, you can't have public S3 objects, I don't care what it is. And what the config wired into a Lambda does is immediately changes the permissioning scheme of that object and sets it to private, which would be kind of fun if people were trying to continually upload public things and can't figure out why they can't download it. So what's a control objective owner then? Control objective owners, if we think back, remember the bedrock of this whole thing is data classification. On the far right side of our matrix, we had a list of controls. We had some things, we had rules about encryption. So control objective owner just means you have someone in place who's checking that stuff. right? Again, we have a conflict of interest if you ask the development team to be a control objective owner. So if your customer comes to you and says, well, it's great that you have these rules about encryption, but how can you prove you're following them? The answer to that question is through a control objective owner. And my proposal then is we adapt SRE to put compliance monitoring in place and be the control objective owner. By doing those two things, you've satisfied what most regulated customers are going to look for when they're checking your practices. I'm going to give you 3 examples about how this could work. Number 1, let's talk about patching. This is a really big deal. You may or may not have heard of this thing called Equifax over the last couple of months. Sort of a big deal, right? So in the Equifax example, this is a really intriguing case for me because patching is actually 2 things. Patching is operating system level patches. So, if you use Microsoft like we do, you get this really fun email once a month with like 400 things in it that are still broken about Windows that we have to fix every month. So there's typically, in an enterprise company like ours, you've got some operations-focused team whose job is to monitor that stuff and roll out patches. And in all honesty, rolling out operating system patches is not that big a deal anymore. It's pretty easy to do. We've been doing it for however long Microsoft has been around. So we've got that problem solved. It's the other side of the problem that's the tricky part, and that's the application layer, and that's what bit Equifax. In the Equifax example, their vulnerability was in the application itself. They used a framework to build their application, and that framework had a flaw in it. An operating system focused team that's focusing on patches would never even know about that. It's not going to show up in your patching tools. It's not going to show up in any of the stuff that we typically use. WSUS doesn't know about it. So how would they even have known, right? And then how do you remediate it? Because I can't push out that kind of patch with PatchLink or with WSUS. It doesn't work. The application team has to pull that patch in, recompile their software, and do a deployment. That's the only way to remediate that patch. So in a traditional enterprise company, those roles are completely split. The tools don't work together, and that disconnect is what caused Equifax to leak 143 million records to the public. In the SRE world, we would do it differently. We would have compliance monitoring in place that covered both ends of the spectrum. We would make sure that the application team, when they built their solution, integrated with our application vulnerability monitoring system. So maybe we're using Artifactory X-Ray or we're using Black Duck software, but that's a part of the process of going live is validating that you're integrated with those tools. Another example, backups. This is a fun one. Oh my God, is that Rachel? Hi, Rachel. Backups. Sorry, I haven't seen Rachel in years. It's good to see you. Backup system. So this is one that our customers ask us about. How do you do backups? And in a hybrid model, when we're doing backups in the data center and we're doing backups on public cloud, having an inconsistent answer does not make your customers happy. You need to have some kind of consistency. By making sure that SRE sits in the middle of all of this, you've got a consistent window into how you are handling patching. There's kind of 2 parts of this. Again, you've got what are the rules, how do I have to do backups, and then how can I prove that I'm actually doing backups? In the SRE world, what we would do is we would have a solution in place that does compliance monitoring, that checks to make sure that every EC2 instance, for example, has a tag on it. And the tag might be something like backup policy -class 1, backup policy -class 2. You get the idea. So we'd be checking to make sure that instances always have those tags. SRE would build a backup solution that would then apply the appropriate backup procedure to those instances. So if you're dealing with your class 1 and your classification document says, this is customer confidential data, it has to be backed up 4 times a day, and the retention needs to be for 12 months. The nice thing is SRE can build that one time and your teams consume it and they don't have to deal with it ever again. And if the regulations change, like they're doing with GDPR, you don't have to go back to your application teams and ask them to change anything. SRE just rolls out the change to the backup procedure, they validate that it's working correctly, and you're good. So now our retention goes from 12 months to 3 because GDPR says you can't hold it longer than that or whatever the case may be. We haven't had to impact our development teams. And the last example I'll give you for how SRE would add a lot of value is in something like key rotation. So think about secrets management in your company. Do you really want every application development team to come up with their own solution for how to manage secrets? Do you really want every app dev team to stand up Vault and figure out all the complexities involved with running Vault? No, you do not. You have wasted a ton of money and time if you're asking your dev teams to do that. If you don't give them that solution, all they're going to do is put their configs and they're going to put them straight in Kubernetes. They're going to put them in their source code, God forbid. That kind of stuff is going to happen because you haven't given them a better solution. And they're not going to want to incur the cost of setting their own stuff over and over again. Again, if your needs change in terms of how often to do key rotations, let's say right now your customers and regulations require you do it once every 30 days. Let's say the regulation changes and now you have to do it more often. By putting one team in place that owns that as a service or a product to all your app dev teams, you can make changes to those types of policies and not impact all your development groups. A couple of do's and don'ts of how to do this. Good things to do. Make sure you have a development playbook. What's a development playbook? It's just some documentation that helps dev teams get started. It's a living set of documentation of best practices about how to do development at your company. You're going to have people coming on board, rolling off of projects. Those things are going to change. Teaching your folks how to go to one place and stay up to date about the best ways to do things or not do things is going to save a lot of friction in your development groups. That said, you should allow deviation from that playbook. Your reliability engineering group should not be dogmatic about following every do and don't in the playbook. It should be principle focused. Okay, so talk about why we need to do backups the way that we do backups. Don't give them a specific thing that they have to do it this way. Backups is a really poor example. Let's talk about high availability, right? So maybe in the playbook you talk about high availability and how to achieve that at Amazon or in your data centers. And you give examples about autoscaling groups and best practices for cluster sizes. Your team may come to you with a better solution. You should be open to that. And the nice thing is, if they prove that they do it better, roll those changes into the playbook so everybody else gets to reap those benefits later. Make sure your SRE group is actually an engineering group that's creating solutions to these common problems. If you don't have folks on your SRE group that can actually maintain a Vault infrastructure or a Kubernetes-focused infrastructure and help your engineering groups keep those things up and running, you're probably not doing this right. You should be providing compliance as a product to your teams. Make sure you don't make that internal compliance check opaque. It's not a black box, okay? The SRE is not staffed with security experts and no one else. It's not a form that people fill out. So I don't create a service internally that I want to launch, and then I go to some Confluence page and I fill out a form. Do you do backups? Yes. Do you do, what's your are you HA? Yeah. Have you done a disaster reliability? Yeah, sure, I've done disaster check, sure. Right? That's what's going to happen if you make it that type of process. SRE should be a collaborative team that's partnering with your development groups to help them build awesome solutions. The flow looks kind of like this. This is a high level. We're going to double click on this in a second. Dev teams develop against the playbook. You go through an operational assurance procedure with reliability engineering. That should be pretty smooth. And then once you do that, the team's ready for production. No one is using it yet necessarily. And then you're going to go through third-party certifications. So you might then go get a SOC 2, FedRAMP, whatever you need to do. Let's walk through this in a little bit more detail. This is what it should actually look like. First things first, development team, hopefully you can read that, does some initial planning. They do an architecture check. They want to build this solution and they're going to think about the best way to do it. They might come to the conclusion that the best way to do it is to deploy it on Amazon. Great, no problem. Now we're going to sit down with our account managers who understand the customers and the landscape of the market where we're going to be deploying that product. We're going to sit down with SRE and the dev team, and we're going to take a look at what that means. What does it actually mean to build this solution for these customers on public cloud? So SRE has a certain bar that they set. Account management might know right away that's not high enough. There's going to be some other stuff that we have to do. And so early on in the development process, we start to become aware of any of these extra type of certifications or checks or features that we need to build in. The team goes off and they start doing that stuff, right? They're doing playbook-based development. At the same time, account management starts socializing with your customers that this change is coming down the pipeline. We do not want to be ready to launch a product and then tell our customers about it, this big architectural change we're about to roll out. Never used public cloud before? let's just go ahead and launch this thing, and we'll tell them about it a couple days ahead of time. That's not going to go over well if you're in a regulated market with these highly critical services that you sell to your customers. So hopefully your account managers have good relationships and they can start socializing these things early in the process. Those inputs feed into the internal certification. Some people call it operational assurance. This is that process where SRE sits down with the dev team and they make them prove everything is actually true that they say is true. Now the team can go live, but no one's using it yet, depending on the service. We're going to revise the playbook with any innovations that they may have discovered. Now we're going to go talk to customers. We're going to go get a SOC 2. We're going to go to our customers in these regulated markets, and we're going to start showing them this new thing. The customer may have their own go-live checklist that they want to go through with us. That's okay. This is the day and age that we live in. SRE is going to be the ones that work with the customers to work through that process. Why? Because now the dev team can go back and start adding in 2.0 features. So we hit our MVP to go live, but there's still lots of other work to be done. So the team's been getting some stats about their deployment process to prod. They're making some improvements there, and they're adding in their next round of features while we start getting the green lights from customers. As we get those things, we're going to turn the feature on for them or the new service on for them. So this is implying a really important technical capability you may or may not have, and that is feature toggling. You have to be able to launch features to production with no impact or change to your customers. You cannot do continuous deployment if you don't have that in place. Okay? There is no such thing as continuous deployment if every time you deploy, your customers are going to see whatever change you just made. You can't do it like that. Okay? There's 3 legs to that stool: feature toggling, really great automation and test coverage, and then the third thing is being able to deploy code without downtime. You got those 3 things, you can do continuous deployment. If you don't have all 3 of those things, you can't. Okay. That's it. I am really proud of you guys. The vast majority of you stayed for the whole thing. It's like way late in the day. Well done. I'll open it up for questions if anyone would like to throw anything or ask questions. Yeah. Oh, this one?
Yeah. I don't see any applications underneath there. What do you guys do?
Great question. So we use PRTG is the primary tool that we use for network level monitoring. Some of our programs use New Relic, and my team uses Datadog. Note the socks. Let me make sure I answer that honestly. Yes. Yes. About 9 people. Am I allowed to say that? All right, good. I'm allowed to say that. Yeah, and the transition to that was interesting because, it's interesting to me. We started out with about 7 people on the release management team and added some heads, and then there was a little bit of turnover, and we kind of settled down at about 9 people to maintain it. So several of them are still from the release management side that it just learned new skills, and it ended up being really good for them, in my opinion, right? Because now I can go on my resume and say, oh, I administrated Splunk, I administrated GitHub Enterprise, and SonarQube, and I learned Amazon, and these are all new tools and technologies that they couldn't boast before. Yes, sir? Oh, great question. Man, this is the... Okay, so I'll try and tell the story really quickly. So when I first joined iPrio, and I'm sharing a lot now, don't tell anyone I told you this story. The teams, to get application logs, would send an email or submit a ticket to the network operations center who had physical access to those machines in production, and they would get back, yes, I know, I did the same thing. They would get back an email with a bunch of attachments, 1 log file per server. And so if you had 10 production servers and there was some problem in production, you get 10 log files you get to search through. It was hell, absolute hell. So that was, when I first joined, it was interesting because I think most people in the leadership team expected me to roll out some kind of release automation tool or something, and I said, no, the first thing we're fixing is monitoring. And my reasoning for that was a couple-fold. Number one, I knew how much time we were wasting doing root cause analysis of bugs. Number two, from a cultural perspective, I think monitoring is one of the best ways to connect your team with the customer. So engineering teams, if you don't have great monitoring systems in place, it can feel very disconnected from what the customer is actually experiencing. But if I see a graph that's showing me, like response times for my application throughout the day, I can translate that into an experience pretty easily. And so improving how we do monitoring was a big goal in the beginning. Now, why did we choose Splunk, and what was the resistance to that? So first of all, Splunk's not nearly as expensive as it used to be. Second of all, I didn't have a lot of resistance to rolling it out. And I'll admit that I kind of purposefully chose a tool that wasn't super easy to use. And that's counterintuitive to a certain extent. But the story that I heard a couple of times was, oh, we used to have this performance monitoring tool, but nobody ever used it. And my theory was it was too easy. And so if you have a tool like, in my opinion, New Relic almost makes it too easy, right? It's like, oh, we just solve all these problems for you. You don't need to think about how to set up alerts. We're going to profile your applications. We're going to automatically set alerts for any deviations. And, like, that crap's, for a company that didn't have any monitoring in place for their dev teams, that was too much too soon. We needed to evolve the culture a little bit first. And so Splunk gave us a great opportunity to do that because you really got to get hands-on with it. You got to learn like their custom query language. You got to think about like how the searches work and indexes, and building your dashboards is not like Datadog where it's super easy and drag and drop. But I wanted our teams to spend time doing that stuff because I needed them to understand the value of the investment in that time. And now we're at a point where tools like New Relic and Datadog make sense. Now we'll consume those things a lot more responsibly than we would have before. No one from IPRIO has thrown anything at me yet, so I assume that's ringing true for them. Other questions? Mr. Cox? I did, yeah, as an example of a build tool. We do have a couple of folks that are still using Jenkins, but they're transitioning over to TeamCity now. We do about between 25 and 30,000 builds a day on TeamCity. We have over 220 concurrently connected build agents. So we run one of the bigger TeamCity installations in the world, as far as I can tell. TeamCity's load testing on their server maxes at 300. They don't even test beyond that. So we're getting close. Any other questions? All right, awesome. I really appreciate the attention and for sticking around. I'll be around up here if you want to come talk to me after. And you can look me up on LinkedIn. Thanks for coming. Appreciate it.